The James Webb Telescope has essentially provided the most precise image of Proxima B in history, revealing breathtaking snippets of knowledge into a potential exoplanet. It obliges us, as we set out on a journey through space in search of the secrets of Proxima B, to find out whether it could be the next Earth. We ought to take off into the vast expanse of space, where a mysterious planet exists in the habitable zone of its star Proxima Centauri. This planet is not just any ordinary rock. Proxima B is the real thing. Found a mere 4.2 light-years from us, this planet is the subject of many mysteries and wonders. Could it be another Earth, with seas and the life that grows there? Wait, there's more. Proxima Centauri B isn't alone in that system. Around the red dwarf star, it has a companion, Proxima Centauri C. And who knows what other mysteries the star system may hold. Perhaps there is another companion we have not yet discovered. But the secrets don't stop there. Proxima Centauri B receives approximately the same amount of energy from its star as Earth does from the Sun. Could this truly mean there's water on its surface? Possibly even life? As we explore beyond our own solar system, we encounter a brand new universe of planets orbiting stars called exoplanets. With 200 billion stars in the universe, the opportunities for exoplanets are endless. Some even wander freely, untethered to any star like space travelers. Among them all, Proxima Centauri B stands out as an especially striking and captivating planet. It has a year that lasts only 112 Earth days, and it orbits closer to its star than Earth does to the Sun. Indeed, one side of the planet is constantly bathed in sunlight, while the other remains in everlasting darkness. Now let's examine Proxima Centauri, the star around which Proxima B revolves. Proxima Centauri is an Alpha Centauri system component. The Alpha Centauri triple star system includes Rigil Kentaurus, also known as Alpha Centauri A, and Alpha Centauri B. Together, these stars form the closest star system to our solar system. Rigil Kentaurus and Alpha Centauri B form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as a single star in the constellation Centaurus and are the third brightest stars in the night sky, with a maximum luminosity just under 2.7. Proxima Centauri, also called Alpha Centauri C, is an M-type red dwarf star, discovered 21 light-years away. It is the closest star to us. In fact, Proxima means the closest in Latin, and it was discovered in 1951 by Scottish astronomer Robert Thorburn. Despite being our closest celestial neighbor, it is not visible to the naked eye, having an apparent magnitude of 11.13, much fainter than the human eye's limit of 6.5. Still, don't let that fool you. Proxima Centauri is a red dwarf star worth studying. Red dwarfs like Proxima Centauri are among the most efficient stars in terms of energy production. Although they don't emit much energy, the internal convection processes in their cores allow them to shine for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it is a flare star, meaning it has frequent and intense explosions. As a low-mass star, its habitable zone is much closer than the Sun's, estimated somewhere in the 0.23 to 0.54 AU range. But it's not necessarily a comfortable place to live. Proxima B is bombarded by intense ultraviolet radiation from its star, far more powerful than the radiation we receive from our Sun. It's so extreme that even the lightest particles of hydrogen, along with oxygen and nitrogen, are stripped away. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may lack a vitally important, stable environment that regulates temperature and supports liquid water. Without it, living creatures would be vulnerable to harsh space weather, making life extremely unlikely. So, while Proxima might appear Earth-like on the surface, it is far from being able to support life. Scientists remain cautious, as many factors render it hostile. The mission to uncover the truth about Proxima B continues, and some still have hope, thanks to a tool that has captured astronomers' attention, the James Webb Telescope. After years of anticipation, The telescope finally launched in late 2018. It will help determine whether life exists on Proxima B. However, as with everything in science, things are rarely as simple as they seem. Several adjustments were required to ensure the James Webb Telescope delivers accurate images. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was designed to detect and capture this infrared light, to analyze the planet's surface and look for patterns that might confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that's not conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a dense atmosphere, significantly denser than Earth's, and surface temperatures that make life impossible. The journey to unravel the mysteries of Proxima B is not without its challenges. While the James Webb Telescope holds great promise, other factors must be considered. With costs mounting, space scientists are feeling the pressure to find more efficient ways to observe planets like Proxima B. Much is at stake, but the potential rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that may hold the potential for life, is a pursuit worth chasing. If the exoplanet were habitable, might we visit it one day? As the exoplanet closest to us, Proxima B is especially captivating, almost like a backyard exploration. The fact that it is nearly identical in size to Earth and located in the habitable zone suggests it could indeed have conditions suitable for life. Likewise, it makes it an ideal target for our quest for life beyond Earth. With it being so close, it's a strong contender for interstellar missions. Think about exploring this Earth-like exoplanet. Although we can't go there yet, it's definitely on the radar for future missions as technology advances. It's one of the most exciting initiatives in the realm of space exploration. On the other hand, it's not an easy task. It would take 75,000 years for a spacecraft similar to Voyager 2 to reach the Proxima Centauri system. Nonetheless, a solution has been proposed. Solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system, and Proxima along with it. This technology uses solar pressure to keep the spacecraft on course and eliminates the problem of running out of fuel. And this is something even more awesome. Cutting-edge technology could provide new perspectives on the possibility of living on other planets similar to Proxima B. Like any ambitious endeavor, there are limitations. For instance, the presence of an environment does not necessarily guarantee the presence of life. Proxima B could resemble Venus, with its intense heat and inhospitable atmosphere. Additionally, get this from James Webb's website, the telescope can detect such emissions if they reach a brightness of only 5% of the daytime side. Now, 5% may not seem like a lot, but when it comes to a star that's generally dimmer than our own sun, it's quite significant. If Proxima B has advanced civilizations, they may use bright orbital reflection mirrors to bring sunlight from the daytime to the nighttime side. How cool is that? There are countless planets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being gigantic gas giants, while others resemble our own Earth. But what do we know about them? One type of exoplanet that has piqued the interest of space scientists is the gas giant. The composition of these planets is comparable to Jupiter and Saturn, but they're much larger. Some of these massive beasts have been identified as super-Jupiters, surpassing even the largest planet in our solar system. Yet not only that, there are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a sweltering zone with temperatures high enough to melt metal. Imagine seeing one of these planets up close, with its violent storms and swirling gas. In addition to extreme heat, Neptunian giants are also found among exoplanets, similar in size to Uranus and Neptune. These include hot Neptunes and smaller Neptune-like planets, which are closer to their host stars than their gas giant cousins. These planets are frequently shrouded in mystery, with their atmospheres being difficult to study from afar. And let's not forget the Earth-like exoplanets, which resemble our own Earth. These planets come in various sizes, ranging from smaller than Earth to twice its size. There are even super-Earths, which have more than twice the mass of our planet but are lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth with an estimated mass of 7 Earth masses. Although it is close to its host star, it is still far enough to be considered within the habitable zone. Proxima Centauri b is not alone. It has Proxima Centauri c as a companion, which is much farther from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. Even more fascinating about Proxima Centauri is that it appears to be an incredibly bright world, possibly due to the presence of a ring system. There's more to learn about the Proxima Centauri system. In 2019, astronomers detected a shift in the star's orbital speed, which could be the result of another planetary companion. If confirmed, this planet will be called Proxima Centauri d and will be roughly the size of Mercury or Mars. Imagine a life where there are a lot of stars in the night sky, as well as countless other planets, each with its own unique characteristics and orbits. The universe is full of surprises. Exoplanets are just one example, and new discoveries are being made constantly. It's an exciting time to be a space scientist. While we don't yet have an accurate count of exoplanets, we do know they exist, just as we know the stars that light up the universe. However, exoplanets are not without their challenges. They are often hidden by the glare of their host stars, making them difficult to study. Still, with advancements in technology, direct exoplanet imaging is now possible. For an exoplanet to be directly imaged, it needs to be big enough to be seen by a telescope, far enough from its host star to avoid being obscured, and young enough to be hot and visible from Earth. These requirements limit the number of exoplanets that can be directly imaged. However, they provide an intriguing glimpse into the attributes and composition of these distant worlds. Exoplanets are most commonly found through the changes they induce in their host stars. The gravitational pull of an exoplanet can cause its host star to wobble. This wobble, measured by radial velocity, can be detected by astronomers. The Kepler Space Telescope utilized the transit technique, which measures the loss of brightness caused when an exoplanet passes in front of its star. This method has given us useful information about exoplanets, including their size, distance, and temperature. Here are a couple of fun facts. Did you know that more than 22% of Sun-like stars have Earth-sized planets in their habitable zones? Or that the TRAPPIST-1 system contains 7 exoplanets with water and rocky terrain on their surfaces. Exoplanets like those in our solar system can also have natural satellites, known as exomoons. With more than 4,000 exoplanets discovered so far, we are aware that they are abundant. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, but countless other exoplanets have yet to be discovered. The James Webb Space Telescope, JWST, from NASA is unveiling the secrets of the universe, one discovery at a time. This remarkable telescope has been gathering data and capturing stunning images of the cosmos, revealing previously unknown wonders. Recently, it made a groundbreaking discovery that could change our understanding of the universe forever. NASA announced that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in a planet's atmosphere. This discovery, which occurs outside our solar system, provides crucial insights into the planet's composition and formation, offering us a glimpse into the mysteries of the universe. This gas giant planet orbits a sun-like star 700 light-years away. The discovery signifies a significant step forward in the search for life on other planets. NASA Administrator Bill Nelson stated that this finding would supply us with a new perspective on the universe, one we've never seen before, sparking excitement among astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has been busy capturing breathtaking images and gathering data about the universe in the infrared spectrum. Light from the young emitting object known as IRAS 11046-4 illuminates cool, wispy cloud material. The orange spots behind the cloud reveal starlight from far away, obscured by ice within the cloud. This remarkable research is part of Webb's Ice Age project, which aims to study the formation of ice from its creation to the formation of frozen comets. And that's not all the James Webb Space Telescope has envisioned. It has captured the workings of a dusty disk in the vicinity of a nearby red dwarf star, doing so for the first time at specific frequencies of light in the infrared.